Hello everyone, in today's video we are going to learn about one of the most commonly used sensors in robotics and automation, that is the IR object detection sensor. In this video we will cover what an IR sensor is, its construction, working principle, pins, what is active high versus active low IR sensor, applications, Arduino Nano interfacing with the passive buzzer and the live demonstration. So, what is an IR sensor? IR stands for infrared. Infrared is a type of electromagnetic radiation with wavelength longer than visible light, approximately 700 nanometers to 1 millimeter. An IR sensor works by transmitting infrared light and detecting the reflected light from nearby object. That's why this module is called IR object detection sensor. The sensor which we can see on the screen is called active IR sensor because it generates its own infrared light using an IR LED and then detects the reflected light using an IR receiver. Now let's see the construction of this IR sensor. First, we can see a white LED here which is known as the IR transmitter. The transparent LED is the infrared transmitter. It continuously emits infrared rays. This black component is the IR receiver. It receives the reflected infrared rays from nearby objects. So here is the LM393 comparator IC. This IC compares the voltage from the receiver with the reference voltage. Based on this comparison, it changes the digital output. Next is this distance adjustment potentiometer. It is used to control the range of this IR sensor. Next is this power LED. The LED glows whenever the module receives power supply. And this is the output LED. This LED turns on whenever an object is detected. Now let's move on to the pins of the IR sensor. There are 3 pins in this IR sensor, which are the VCC, ground and output. The VCC pin supplies 5 volts supply to the sensor and its components. Next, ground is connected to the Arduino ground and the out pin sends the digital signal to the Arduino. Let's understand the complete working of the sensor. The IR LED continuously emits infrared rays. If there is no object in front of the sensor, these rays travel forward and do not return to the receiver. As a result, the receiver detects very little infrared light and does not detect the object. However, when an object comes in front of the sensor, the emitted infrared rays strike the object surface and reflect back towards the receiver. The receiver converts the reflected light into an electrical signal. This signal is sent to the LM393 comparator IC. The comparator compares the received signal with the reference value set by the potentiometer. Thus, the output is then read by the Arduino. So, following is the list of components that will be required for the integration of IR sensor and buzzer with the Arduino Nano. First, we will require Arduino Nano shield, buzzer, IR sensor, jumper cables and USB data cable. Now let's do the connection. Our IR sensor has 3 pins, VCC, ground and Dout. We have to connect the VCC to the VCC of the Arduino shield. Then we have to connect the ground with the ground. And at last, we have to connect the Dout pin to the pin number 2 of the Arduino shield, that is D2. Now let's connect the buzzer. For the buzzer, we have to connect the ground, that is negative pin of the buzzer, to the ground of the Arduino shield and the signal pin to the T9 pin of the Arduino shield. Now we will upload the code in the Arduino Nano using Arduino IDE software. Open Arduino IDE and insert the code of the buzzer and IR sensor in the Arduino IDE. Here the code is already inserted in Arduino IDE. As we can see, IR sensor is connected to pin number 2 and buzzer is connected to pin number 9. Once the code is inserted, verify the code. And then upload the code in Arduino Nano. Once the code is uploaded, connect the Arduino shield and Arduino Nano and then connect the data cable to the Arduino Nano. Now here, as we can see, the power LED is on. That means the IR sensor is receiving the power supply. Now when the IR sensor will detect an object, then the signal LED will glow. Now let's test the IR sensor. Now there is no object in front of the sensor. That's why the buzzer remains off. As soon as any objects come in front of the sensor, the signal LED will glow and the buzzer will turn on. Now, as I place my hand in front of the IR sensor, the infrared rays reflect back to the receiver. The sensor detects the objects, the output becomes high and Arduino activates the passive buzzer. Okay, we can also rotate the blue potentiometer to increase or decrease the sensing distance. So that's everything you need to know about the IR obstacle detection sensor. IR sensors are widely used in obstacle avoidance robots, line follower robots, object counters, automatic doors, smart parking systems, conveyor belt automation, security alarms, and industrial automation.